Hello everybody, we're ready to get started. If you haven't already, there is food back in the back. Thanks to Tech Systems. Thanks to the Iron Yard for providing the space for us. And of course, thank you all for showing up. Tonight we've got Michael Ritchie talking about high performance websites. Michael, you ready?
Yeah.
All right.
Evening, folks. I'm Mike. I'm here to talk about building high performance websites with ASP.NET. Most of the code samples in this class is from ASP.NET 4.0. So the implementation would change a little bit for 5.0, but the principles are all the same. In fact, the principles will apply to non-Microsoft developed sites. It's pretty much a web app, high performance web app class overall. So the average human has an attention span of 8 seconds. In the year 2000, we had an attention span of 12 seconds. A goldfish has an attention span of 9 seconds. It's the mobile revolution that happened since 2000. We're all trained to look at our phones and check Facebook and click on things and go somewhere else, and our attention spans have gotten smaller and smaller and smaller. So Amazon.com calculated that 1 second in slowdown on page load costs them $1.6 billion a year. 1 second. 4 in 10 Americans will give up accessing a mobile application if it loads in less than 3 seconds. Studies show that page load time under 3 seconds has the same conversion rate as instant load time. What's that tell us? That tells us that the optimal load time for an application is 3 seconds. Any shorter and you don't get that much benefit out of it. Any longer, you're losing money, you're losing viewers. The median load time for US retail site is 7.25 seconds, more than double the time. It's optimal. So it's costing money. It's costing you users, it's costing you interactions, it's costing you page views. So why are our sites so slow? Anybody want to have a guess? Somebody. You can interact.
Too much content.
Too much content. Anybody else?
No caching.
Caching where?
Say caching on like a search platform.
Okay. Anybody else?
Bad queries.
Bad queries. So, when I first started giving this talk years ago, I would get a lot more answers about things happening on the server side. But when the top 50 websites in the US were surveyed, they determined that only 20% of the load time was spent on the server. So the server building the page and spitting it out to the network was only 20% of the time. The rest of the time was all the components downloading and the browser dealing with those and rendering them. So why is this? It's because the internet's huge. This is a tracer route to Baidu.com, which is one of the largest sites in China, from Tampa, Florida. And you can see how many hops I went through. You notice down here there's some timeouts. I guess the Great Firewall of China doesn't like you doing a tracer route, so they dropped me out there. But the internet's big, and if you're not next to your server, it's a long path to get to where you're at. So if most of our time is spent outside the server, that's where we're most likely to get the most performance benefits, by shrinking that part down. So what do you need? You need some common sense guidelines to follow that will actually help you reduce your load time on your site. Now, this research has been going on for a while. It started at Yahoo way back in the day. If you're under 30, you might not realize that Yahoo was important at one time. Not so much now, but they were the man in the day. They were bigger than Google. And the research started back then and carried forward about actually how to increase this speed of your page load time. And they come up with 43 different recommendations for to increase your load time of your page. Google took that research, and they have a speed website, and they kind of boiled it down into 6, but they dropped about half of Yahoo's research and said, oh, well, that's the slower end of it. We'll just drop that. And so they condensed it down to 5 or 6, but they covered different things and kind of lost what was there before. So what I've tried to do is actually take the research that's been done in the last 12 to 13 years and kind of boil it down into some common sense guidelines that you can kind of follow. And then each guideline, I have 6 guidelines, has some implementation details, and we'll discuss each of those. So, guideline 1 is to make less trips. When you actually measure the time spent from the server serving the files till it's actually usable on the browser, the majority of the time is in the HTTP request. The more requests you make, not the size of the load, the more requests you make, the slower that page will render. So if you can reduce the number of those requests down to a smaller number, you will have the biggest increase in your page load time. So, guideline 1 is to make less trips, right? Make less requests and convert those images into one image called a CSS sprite. So, there's not a lot of code demo tonight, but there is a little bit, and this is part of it. I'm going to leave the presentation and actually go to a sample application. So this is a sample application that I built by taking a pre-made template and applying it to an ASP.NET framework. This is a responsive template, which means that it changes based upon the size of the browser and actually goes down into a mobile template. So let me scroll through here so you can see that it works. And so this is something common you might encounter in development these days. So this being our representative site, you'll see that there's quite a few images on it. Most sites have images today. So instead of having an HTTP request for each one of those images, what you do is you put all the images into one file and you send that file to the browser. And then you put in style sheet directives to actually use a piece of that image instead of the whole image. So let me show you what that looks like. This is Photoshop. This is all the images from that page into one file. And I'm going to save this off as a JPEG and send that down to the browser. So in this case, there's 15 images. So instead of 15 HTTP requests, I have 1. Okay? So in the CSS, I put instructions in there to actually use a piece of that image. So I won't go into that in too much detail because it's pretty well known. You can Google it and look it up. But what I want to show you about this site is something that's a little bit newer. The images on this site actually change size. You see that? Based upon the size of the browser. That way it will work for a mobile site. You see that?
You just skipped over something that I've never seen before.
What's that?
That CSS sprite, putting it all in one image and doing that. You act like that's trivial. It's not. And I've edited it all over for 25 years.
It's been around for a while. I can give you links to it later. I'm going to show you a little bit different method of that right here. CSS sprites, the normal traditional way to do it will not work when you're doing reflexive images like this, where you're actually changing the size of the image. And the reason why is that when you want the images to do that, your CSS actually has to have a percentage for each image in there. So go into the file and use 25% of the width and 10% of the height, right? So to do that, you can sit down and do a lot of math, right? Or you can use this tool here, which is called CSS Sprites. They have a responsive version of it. And what you do here is you upload all the files that you're going to use. So I'm going to go in here and let me go back to my images that are in the site I was showing you. I'm going to pick those out. So let's go here. I have a banner. And I think I had that one. 1 through 7. One, 2, 3, 6, 7. Okay. So I'm going to send it all my images You have an option to do JPEG or PNG. I would do JPEG. It says PNG recommended. Ignore that. It'll make a file so huge your site will never load. It asks for a prefix. This allows you to not conflict with any existing CSS, so I'll just put ASDF on it for now. And then it asks you how much padding you want between the images. I'm going to put 1 pixel and create sprite. Now, what this did was create one image that had all my images in it. You see this here? In fact, if I drag it up here, nope, got to download it. Yep, there it is. It's one image that has all my other images combined. You see that there? It's very similar to the one that I created in Photoshop myself. The difference is this site also gives me the CSS with specific classes on it and the percentages I need for that to work, and it gives me the image tags here. Okay? One of the techniques that this uses is it actually puts some data for the height and width, the initial height and width, in the image source tag, and we'll discuss later why that's important. And then it demos you down here. It basically uses its one image to show you that it all works. That way, if there was a problem, you would see right here before you even took the code and tried to use it. Okay? So you would just download this single image. Let me just save it here. And that's the image it created for you. So I'm going to load that one image in the CSS in the background and let the browser cache it so I don't have to load 7 or 8 images by making a request for it. I just make one request. Okay? Now, a couple caveats to this technique when you do use it. One is that tool, while it does a good job of creating the CSS and the image tags for you, it doesn't do a good job of compressing the images. They either look bad or they still are rather large, which is supposed to make, those combined are supposed to not only be one request in one image, but also the total size should be smaller than the images together. It doesn't do a great job of that, so what I do is actually pull that image into Photoshop, get my originals, line them up on top of it, and then I get to use the Photoshop tools to determine the quality of image I want to save down, right? So I could actually compress it even more than it did and still get a better looking image. You can use it as it is, but it looks better if you pull it back into Photoshop and put your images over top of the ones that it created. Okay? Next tip is to put all your scripts into one file, right? So the traditional way, you can see right here, is for every different script that you have, you create a script tag and then it downloads those individually, right? That's going to make 1, 2, 3, 4, 5, 6, 7, 8 in the example HTTP request. So to get those requests down, you actually want to combine those scripts into one file. You can do that manually, right? As long as you put them in the same order, it'll work exactly the same in your browser. But ASP.NET actually gives you this file called bundle config, and part of the framework uses this file and makes a single jQuery file that you can download. Not jQuery, but JavaScript file. Okay? So the way it works is in the bundle config file, use this syntax here. If you create a project in Visual Studio, it creates this file for you. You can go in there and follow the format. But if you see here, I've said create a new script bundle. I gave it a name, right? Bundle/all script. This turns into a virtual directory that's not really there, but when you request that, it will return the contents of these files. And then I'll list out each of my JavaScript files that I was going to do individually. I put them into this bundle. And then in my layout page, my master layout page, or you can do this in an individual page, I use this command here, @scripts.render, and I put in the same name that I put here. That will give me a single script tag that will download all these as one file. So that reduces my HTTP request. Next thing to do is to combine all the CSS into one file, all right? So when you create a Microsoft project and then you go get a template from somebody else, maybe a designer created it for you or you bought one and you apply it, there's 2 CSS files there. A lot of times when you add controls into your application, you end up with more CSS. So it behooves you to keep those separate because if the control gets updated, you just go get it and replace the file. But each one of those turns out to be a HTTP request. So what you want to do is instead of doing individual requests like you do here, you want to go inside the bundle config, create a bundle for your style, include each of those files so they're still separate. You can work with them separately like you had before. And if a vendor updates one, you can just go grab it and replace it, recompile and test. And then in your layout file or an individual page, you can render all that as a single file. So now we've replaced 3 HTTP requests with 1. So we're getting that number down, and that's where we can get the most performance. Next tip is to make all scripts external. Okay, a lot of people will have a script like this. This is just something I grabbed as an example in their code because in your mind, well, I'm just doing this one thing on this one page, so I'll just write it and I'll leave it there. But as a site grows, there tends to be a lot of duplicate scripts on multiple pages. If they're not exactly the same, they're siblings. They're 9% the same, and you can actually combine those into a library. Just do a little rewrite work. Okay? You want to get those out of the page and get them into the external file. You need to put your scripts, you need to have at least one external file. You may as well get all of your script that you can out into that file so that it can be cached and you can take advantage of that. Okay? So you need to get that out of the file, shorten the file size. Remove duplicate scripts. A study of the 50 largest websites on the web found that 40% contain duplicate scripts. Got a big website like msn.com, probably has 30 or 40 developers working on there, a bunch more content creators. They end up with duplicate scripts on the site. Absolute waste of resources. So you need to objectively look for those, find them, move them into common libraries, get them out of the files. Okay? So not only is it doing the same work twice, you're downloading the same payload twice, you're also creating a situation where it may not work. Okay? And look at these guys. Do we really need 2 of these guys hanging around? Next tip, use get for Ajax. So there's really 2 ways to do a request if you're using Ajax in that application. You can do HTTP get or HTTP post. The truth is, post uses 2 HTTP requests to complete its operations. Get uses 1. Okay? There are size limitations on what you can do in get, but if at all possible, you should be using get because you're cutting the number of requests down from 2 to 1 by using get. But be aware of that overhead.
What about that axis? You shouldn't use gets for modifying data on a server. Stick with posts or updates and inserts.
It's obviously not a. This is a guideline instead of a commandment. But to increase page load time, this will get your HTTP request down. Okay. Next tip: avoid empty source tags in Ajax. So a lot of people now are doing some interesting things with images. A good example is what I was just doing, where I'm building reflexive images that will change shape, and I was using a sprite so they're all in one. If you leave the source tag empty on an image right here, everything seems to work fine, but the browser makes a request for the same directory as the file that it's contained in. And if the default on that directory is to return an index file, guess what? When you do that, an entire page and everything it contains comes down with it. So not only is it another HTTP request that you didn't need, it actually has a big payload with it. Okay? The newest browsers of Firefox and anything built on WebKit and Google Chrome do not do this. So they fixed it in the newest browsers, right? But you look three or four versions back, you're going to have this problem. So don't do this. Don't leave empty source tags. You got to put something in there. Okay. Now the example I've shown you, it put an encoded image that basically set a height and width so that it wouldn't do this, and avoids that problem. Other things to keep in mind on Guideline 1. iPhones don't cache anything over 25K long term, right? So if you're combining everything to reduce HTTP requests and your combined files are more than 25K, if mobile is a big piece of the picture, you might want to consider breaking them up, right? So generally you're trying to limit the number of, you're trying to get everything into one file, but when you're talking about mobile, if the file's too big, it won't cache it. So the next time they come back in 3 hours, it's not cached your file because it was too big, it threw it away. It's worried about space. So keep that in mind if mobile is a big factor in that particular application. Second tip to keep in mind is HTTP multipart documents. HTTP multipart documents is a way to encode images, script, and other things within the HTML document. If you're trying to do something with, say, Internet of Things, where you have a very small device and you want to limit what that device is doing, a multipart document may be a good solution. In general, for web applications and websites off of a web server, it's not a performance increase, but in certain situations it could be, so you could consider that. Guideline 2, make shorter trips and get some help. So if I'm trying to limit my number of trips I'm making to the server, right, wouldn't it be great if it wasn't as far? Okay, so the number of hops that you're making through routers adds significantly to the time it takes for your request to be sent, everything to come back, and for your browser to render. So if you can make those shorter, that will behoove you. So first tip, use a content delivery network, a CDN. Does everybody know what a CDN is? Okay, everybody got that pretty good? So you know what they are, use them. If you want to use this with the script bundles that I mentioned before, inside the file you have to turn bundles UCDN to true, and then you add them very similarly that you did the other files. So you create a new script bundle. I called this outsource to CDN, and I gave it the address of the CDN. Okay? Then I added this .include. You see that? And this is my local version of each of those files. Why did I give it the local version? I can set debug to use the local versions. So if I'm in debug mode and I launch into debug mode, I'm going through my local files, which are uncompressed, and right there, and I can look at them. The ones you put in the CDN are usually compressed, and they're out there, right? You're pulling down somebody else's file. So this allows you to debug without much trouble.
You do that with more than one CDN like that?
Yes, you can.
I'll see two parameters.
What's that? Well, I cut this off here.
No, but the CDN one is the second one, isn't it? The second parameter is the CDN parameter. The third parameter is your stuff. What if I've got more than one CDN?
Actually, this is a comment. You see I left a comment in there? So I've cut something off here that you're not seeing. It's cut off a comment. So I've posted something wrong in there. The first line here is how you add it. And then the second line would be how you
The first
do the
parameter
input.
is the name of the script. The second parameter is the name of the CDN. I don't get it by looking at that.
This is the first parameter is the name that's going to be put in my file.
Right.
How the browser sees it.
Right.
The second parameter is the name of the CDN, and it got cut off.
Yeah, what if I've got 10 CDNs? I can just put commas after them. Does it take very
No, you do a different line for each CDN because that's different requests.
Okay.
Right?
Okay, so it can't combine CDNs is what you're telling me.
No, it's different systems, right? Second line
I was
is
going to ask you that
yeah.
before.
Ignore the second line. Third line is where my debug scripts are. Okay. Any more questions?
Thank you.
Okay. Better yet, use the other guy's CDN, right? So if a CDN works so well and someone else is giving you a CDN, right? So Google puts all the jQuery files up on their CDN for you to use. Why would you not use the other guy's CDN? Doesn't cost you any money. Google has a much better CDN than whatever you're paying for. Even if you're paying for Google's, they're going to get priority, so use theirs. Or you can add the bundle in, just like we did before. You're using their CDN, right? This is a direct script I would put in the file the old way. This is doing it with the bundles, so I can also debug jQuery, okay? Next tip, reduce the number of DNS lookups. So, all DNS is a big dictionary, right? When you say CNN.com, your browser has to say, what number is that really? What's the IP address? And it has to go to the DNS, ask them to resolve it. It gives them an actual numeric address, and it uses it to go out to the site, okay? So, there's caching involved. So, wherever your DNS server is in relative to your client, I can make a request there. The operating system also makes a cache of those DNS requests, and then the browser makes another cache of those DNS requests. So if you get to debugging this, it can get a little squirrely. But the more DNS lookups that you create within your file, the longer it will take for that page to render. Okay. Now, once the DNS is looked up once and saved, you're kind of avoided that. But be aware of that. Some people will try to get tricky and create a lot of different DNSs within their page from different resources. That's adding to the load time. Next tip is to split components across domains. Now this seems like it's going against the previous one, but it's really not, because there's a bell curve of what works better and worse. And the reason why is, if I wanted my images to load faster, I can actually put them under a different domain. In this example, I've used the subdomain that all my images are under, but my main website is here. The reason why is, older browsers can only make 2 simultaneous requests to 2 different DNS at the same time. So it'll just open up 2 pipes, and until it gets that payload download, it won't open up 2 more. When you get to the newer browsers, the last 2 or 3 versions, they've bumped it up to 6. Okay? But you can still only have 6 simultaneous requests going on to the same DNS name. So how you can get around that is, I can have my application code under one domain, all my images in another, have my jQuery under another, and the browser will grab all those and pull them down at the same time. So I'm increasing my speed in that way, right? So a little bit of research was done on this, and remember the previous tip was don't have too many DNS names, and they determined that you want anywhere from 4 to 6 different domain names within your includes will give you the optimal amount of downloads. If you get more than 6, you pay too high a price for the DNS lookups, and if you get less than 4, you tend to be bottlenecked waiting on the next thing to open up. So
it's strictly a browser thing where I can have all my DNS lookups map to the same host, so I get the currency off the browser, I get the 6 requests, but it's really just going to one website. I'm just thinking about maintenance.
well, it's a browser thing, yeah. If the website is implementing multiple DNSs, it's all the same.
Okay.
Yeah. Yeah. So, guideline 3, don't repeat trips. If I go to the server and get something and haul it all the way back from China, right? Why would I go back and get that same thing again, right? So we don't want to do that. So, first tip, cache anything that doesn't change, okay? So in this instance, when I say cache, I mean on the browser, right? So the browser automatically caches things for a little while, and it'll make a request to the server with the file date that's on it and ask the server if it needs to get a new one. But that's still an HTTP request, even though the server will tell it, keep the one you got. It still made a request. But you can actually set caching on the files as they come out so that the browser knows, I don't even have to ask. You told me this was good for a month or 2 months before I make any request again, right? So that's actually set in the web config under the static content. You can tell it what type of files and how long to cache them. So in this example, I've set the cache control to 365 days. and I've told it to do it on all GIF files and all JavaScript files. So the browser will not attempt to get those again for a whole year.
So what if you push new changes into JavaScript files? How do you do that?
ASP.NET has a mechanism for that where it actually puts a version number in the file that isn't really there in these bundles. And so that when you do a recompile, it changes that number so it's a new signature and the browser will grab it again.
You gotta be in the bundle though to do that.
No, you can do it. You can do it on other things without the bundle, and you can also do it through, say, Azure CDN. You can have it work off of those also. So there's more than one way to do it. This is only one way to do caching. You can also set it in IIS. You can set it in Azure. So it's not a one place to do the same thing, but this is just one method to do it.
What is kernel cache policy?
I don't know that off the top of my head.
I don't either.
Next tip, configure e-tags, okay? A lot of people haven't even heard of e-tags. E-tags is a little number that IIS uses to keep track of if you have a application running in a server farm, where did that file originally come from? So it puts an e-tag on it and it gives it a number. If that file changes, when the browser makes the request, the browser will still make the request. It's not caching. The browser will still make the request, but it'll pass the e-number back, and that helps the web server when it gets hit to determine if the file that it gave you was off the same server. If it's not, it reserves it again. Okay? So if your application moves into a server farm, the e-tags can really mess you up about with caching, because it's going to resend those files if every request goes to a different server. So I could discuss e-tags for an hour, but the one thing you need to know is they need to be set to 0, and that's what's happening here. In the web config, you're setting the e-tag to 0. Okay? That way, it doesn't become a factor. It's always blank. So it always matches. Okay? If you're hosting in Azure, I just found out this out recently by accident. Azure actually is injecting a host header with another number on it to determine what server you were on in that web farm. So not only do you have to worry about the e-tags, you got to think about that too. Okay? So
Can you explain that again? I kind of lost me there.
instead of using e-tags in Azure, which you can still, I don't think they stop you from using them, the Azure farm actually injects a host header tag into every page that has another number on it, so they can track what server you hit last when you came to the farm. I don't know a lot of details of that because I just found it, but it's something else to consider when you're working in the server farm. Next tip is to cache your AJAX request. Sometimes the little things matter most, and especially when there's a lot of them. Okay? People have been building web applications for a while. We've kind of got the idea of this caching. I want to cache a page. I want to, if it doesn't change, I want to cache images or JavaScript files that don't change very often. But now that we're building more AJAX files, the response from an AJAX request, if it doesn't change that often, it can be cached. You can set a host header on it and cache it in the browser so you don't have to do it again. How many people have had a database driven of, say, states for addresses? It's database driven. But then in memory on the web server, you stuck that in memory so you didn't have to make that database call, right? This is the same thing. If you have a jQuery call to get state names, we're not going to add a state anytime soon. The first time it comes down to the browser, cache that whole jQuery call, right? That way it never has to be made again. So you can do the same thing. Next tip. What?
How do you do it?
Huh?
How do you do it?
Really the same way that we were doing it in the web config on the individual pages. You can set your calls to jQuery based on their signature to do the same thing. So,
Figure it out.
A lot of front-end libraries have a cache key when you set it to true. So jQuery, Ajax calls,
Okay.
so forth.
yep.
I'll look it up.
So, next tip, avoid making a water haul. Anybody know what a water haul is? Water haul is when a boat goes to port, they don't have anything to ship out and they need to go somewhere else. They fill the hull full of water because a big ship cannot run empty. If it gets out to sea empty, flips over. Okay, it's sitting too high in the water. It's got a water haul. So it's a worthless load. So you don't want to make water hauls in your application. So as you build and maintain applications and things change over time, it's real easy to say, okay, these requests that were coming to the server, I'm going to do 404s or 401s and move them around to where I want to go. But the sad fact is the browser made a request and had to deal with that request and then make another request to go where it was supposed to go in the first place. So if at all possible, don't use those temporary fixes of doing redirects to things that have moved to a new place. Fix your code. Go back and fix your code to where it goes the right place in the first place. Then you've avoided that double HTTP request, okay? Don't make those water hauls and bringing things back you don't need. Better than avoiding the second trip, don't make the first trip, right? This is the same as use the other guy's CDN. If I'm using Google CDN for jQuery, and so is half the other applications on the internet, guess what happens when you come to my application the first time? That file is already cached in your browser. The trip is never made because I got it when I visited Amazon.com and they were using jQuery, okay? So that's another reason to use somebody else's CDN. Besides the cost and besides the performance, is it's probably already there before they ever come to your application the first time. It's waiting on you. Guideline 4, reduce the size of the load, right? If we're bringing all this stuff back across the internet, if it's smaller, it's going to come faster, right? It's pretty simple. So how do we do that? So the number one way to do that is to actually gzip the components, okay? So a lot of people are not familiar with gzipping on a web server because it's on by default in IIS and they don't even think about it happening, okay? But what's happening with gzip is IIS is taking the files that you've marked for gzip, it's compressing them, it's running zip on it, right? Just like the zip you use on your desktop, it's a similar algorithm. Gzip is an older algorithm that doesn't compress as much as what you use on your desktop, but it does it much faster. So the reason we kind of stopped at gzip instead of updating is because it has to happen fast, right? So there's a bell curve between compression and time for compression, right? So gzip compresses the files and then sends them to your browser, and your browser grabs the files and opens them up, okay? So when you first make a connection with a web server, that's one of the things it tells the web server is, I support gzip. Almost all new browsers support gzip, so you don't have to worry about the browser supporting it. You just got to make sure it's turned on the server, okay? You can configure what's compressed off the default by going into the web config file in the web server section, turning on static compression to make sure that it's on, and you can tell it what type of files to compress. Here we're doing text, here we're doing anything that's a MIME type of message, anything a MIME type of JavaScript, okay? It's going to take that and compress it. You don't want to compress image files. Does anybody know why? They're already compressed. They should be, okay? So anytime you save off a JPEG file or a GIF file from any decent editor, it's doing compression on it, and you get to select it, right? If you're building an application, you want to compress that as much as possible, and so that's a whole other class. But they should already be compressed, so you don't want to have the web server run compress again. You ever zip a zip file to see what happens? Anybody ever do that?
No.
I have. What happens? It gets a little bit bigger. Yeah, because you're compressing something that's already compressed, so it doesn't really help. Okay, so you don't want the server to do that work.
That page that you just did, I do that in IIS. There's an application config file that's used for the web server.
Right.
So I set the entire web server to do that.
Yeah, and then Azure has configurations for it if you're doing that.
JavaScript and the jQuery files are not set by default. You have to go in there and set.
Right, right, because they may be compressed already. We may talk about that in a minute. Minify your JavaScript and CSS. Perfect timing, okay? What's minifying? Minifying is not compression. Minifying is taking out all the redundant, needless information in JavaScript file, so all your carriage returns, all your spaces that don't mean anything to the compiler, it takes those out, and then any large variable names, it replaces them with real short, small variable names. So it makes the file much smaller. You can run minify in external tools on JavaScript and CSS, but it's actually built into this bundler. And so it will do that minification for you too. Okay? And if you're using a large library like jQuery, they provide you the minified files. So don't try to outdo them. They've done a good job. Just use their minified files. Okay? So that's why it's important to determine what you're compressing in gzip. And in the bundles here, you can see I'm actually using the minified version, then adding the include of the regular version that's on my disk. So if I have to do debug, I don't want to debug through a minified version, right? Because it won't make any sense. Okay? So a quick note, if you obfuscate a JavaScript file, which is run a utility on it that's made to scramble the code so it works the same but isn't readable, you can actually get a little more compression on it. The problem is most obfuscators actually have the overhead of they could actually cause an error because they're much more aggressive in how they manipulate the file. So you have to keep that in mind. If you're trying to squeeze every little bit out of it, you can also obfuscate your JavaScript code, which is normally done to hide it from people decompiling it, but also makes it a little bit smaller, but you run that risk of having errors based on just that. Okay? Next tip is reduce cookie size. Okay? So here's an example of what not to do. Okay? And lots of frameworks do this. They're getting a new user object, and what's in that new user object? Name, address, user ID, right? All kinds of information. I'm sticking it in my cookie, and it's so convenient in my code, I'm telling it to keep it for 365 days, cache it, and I'm adding that cookie, right? So that cookie's good. It's good for 365 days, and it's cached on the browser, and it has all my user information in it. Guess what? When you write something to a cookie, every request after that, that cookie is sent with that HTTP request. And every response from the server, that cookie is sent back. So you stick a big payload in a cookie, you're throwing that ball back and forth to that server from then on. And you're carrying data, you don't need to do it, right? So unless the browser really needs to have all my user information everywhere, why would I do that? I could much easier just say the user and put their user ID in here, and then whenever I need their user ID on the server, user information on the server, I just grab it from the database and read it and do my thing and send it back. Okay? Instead of bouncing that data back and forth on every request after that. So keep your cookies small. That was one of the big performance issues in traditional ASP.NET. They put a lot of stuff in cookies, and it was going back and forth, and it just slowed it down. Optimize your images, okay, including your sprites. Remember I mentioned that tool that I showed you, it made that sprite with all the calculations done for me, but it made a really bad image file, right? It combined them, but the quality wasn't good.